So, an 80 kilogram man is standing on a scale on an elevator. He experiences the vertical velocity versus time shown in the graph above. What is the man's weight at t equals 1 second, 4 seconds, and 8 seconds? All right, so we're also given this graph as stated in the question, and we're only going to be looking at the velocity, the acceleration of this graph, and not the velocity, so just remember that. And here's also an image that I drew of what's actually happening in this situation. So as you can see, there's a man in an elevator who's standing on a scale, but that's irrelevant. And you can see that that there's always an acting force on gravity, and there's always going to be an acting force whether the man is going up or he's going down. All right, so like say in the question, we want to find what the man's weight is at t equals 1 second, 4 seconds, and 8 seconds. So we do that by using the equation weight equals mass times acceleration plus gravity. So given the info, and so the given information that we received was m equals 80 kilograms as stated in the question, and obviously gravity will always be 9.8 meters per second. So let's go to when t equals 1 second. When t equals 1 second, as you can see, t equals 1 over here, and it goes up to 4. And this is clearly constant too, right? So we can see that the acceleration is going to be 4 meters per second squared. So acceleration will equal 4 meters per second squared. So let's plug that into the equation that we have of y equals m times a plus g, which will get us 80 kilograms times 4 meters per second plus 9.8 meters per second squared, which gives us 80 kilograms times 13.8 meters per second squared, which will result us in 1,104 newtons. All right, so when t equals 4 seconds. So when t equals 4 seconds, as you can see that there's literally no acceleration. It's like constant, it's steady, right? So acceleration will just simply be 0 meters per second squared. So let's plug this all back into the equation just so we did before. It'll be 80 kilograms times 0 plus 9.8 meters per second squared, which will just simply get us 80 kilograms times 9.8 meters per second squared. And that will get us 784 newtons. And this actually, like, as you can see, this makes sense because, and this is actually lower than this. Because when you're going up, when there's a positive acceleration, you should be weighing heavier. So when you're going up. And when t equals 8 seconds, the acceleration is -2. As you can see, that is decreasing, so it'll be -2 meters per second squared. So just plug that all into the information. W equals 80 kilograms times -2 plus 9.8 meters per second squared. This will simply get us 80 kilograms times 7.8 meters per second squared, which will get us 624 newtons. So in conclusion, you see that when t equals 1 second, it is 1,104 newtons. T equals 4 seconds, it's 784 newtons, and t equals 8 seconds, 624. And again, this all makes sense because when you're going down, you're going to be weighing less than when you're going up because of how gravity works. Your full weight is not on the elevator when you're going down, so you'll weigh less. So yeah, in conclusion, these are the answers. T equals 1, once again, is 1,104 newtons. T equals 4 seconds, it will be 784 newtons. And at t equals 8 seconds, the weight will be 624 newtons.